Welcome to our tutorial on using TensorFlow for facial recognition. Today, we'll unlock the power of computer vision and machine learning to create a facial recognition system from scratch. Whether you're a beginner or looking to expand your skills, this tutorial is perfect for you. Let's get started. First things first, let's set up our environment. You will need Python installed on your computer along with some packages. We recommend using Anaconda to manage your Python installations and packages. Once you have Anaconda installed, you can create a new environment specifically for this project. Activate the environment you just created by running the following command. This step is crucial as it ensures that the packages we install won't interfere with other projects. Now, let's install TensorFlow. You can install the latest version by executing the following command. If you have GPU acceleration available, ensure you install the GPU version for better performance. We also need to install other essential libraries: OpenCV for video processing, NumPy for numerical operations, and Matplotlib for plotting. With our environment set up, let's dive into our project. We'll begin by importing the libraries we need. In Python, you can import libraries using the import keyword. Here's how to import TensorFlow, OpenCV, NumPy, and Matplotlib. Next, we need to load a dataset for our facial recognition task. We'll be using the labeled faces in the wild dataset, which is available through scikit-learn. This dataset contains a variety of labeled images for our training. Once we have our data loaded, let's explore its structure. This dataset contains images and their corresponding labels. We can access the images using data.images and the labels using data.target. To visualize the dataset, let's plot a few images using Matplotlib. This will give us an idea about what our data looks like before we proceed with the training process. Now that we have a sense of our data, let's proceed to pre-process the images. Pre-processing steps usually involve resizing images, normalizing pixel values, and reshaping data. In this case, we'll reshape our data to compatibility for TensorFlow. Next, we split our dataset into training and testing sets. This is an important step to evaluate the model's performance later. We'll use train under split from scikit-learn for this. With our data now prepared and split, we can build our facial recognition model. We'll create a convolutional neural network, CNN, using TensorFlow's Keras API. Let's outline the model architecture. Now we need to compile our model. In this step, we specify the optimizer, the loss function, and metrics to observe during training. We'll use Atom as our optimizer, sparse categorical cross-entropy as the loss function since our labels are integers, and accuracy as our metric. It's time to train our model. We'll use the fit method for this purpose. We define the number of epochs and the batch size. Feel free to adjust the batch size and epochs according to your computational resources. While the model is training, it's a good practice to visualize the training process. Let's plot the accuracy and loss over the epochs to see how well our model is performing. Training is complete. Let's evaluate the model on the test set to see how well it performs on unseen data. We will use the evaluate method for this. We've reached a crucial part of our tutorial, using our trained model for facial recognition. We can accomplish this by capturing video input using OpenCV. Let's write a function that will capture video from the webcam and recognize faces in real time. In the recognize_faces function, we start capturing video using OpenCV's video capture. We'll use a function called detect_faces to find faces in the video frames, which we'll implement shortly. Now, let's implement the face detection function. For simplicity, we can use HAR cascades, which are ideal for this purpose. OpenCV provides several pre-trained HAR cascade classifiers. We can load the frontal face HAR cascade as follows. This detect_faces function takes an image, converts it to gray, and detects faces using the loaded HAR cascade. The function returns coordinates of detected faces that we can use to draw rectangles. Now, we have all the components ready. Let's run our facial recognition program. Call the recognize_faces function at the end of your script to start capturing video. Make sure to be in a well-lit environment for better accuracy. As a summary, we've built a facial recognition system using TensorFlow that includes data preparation, model training, and recognizing faces in real time. This is just the foundation. You can expand this project by adding features such as saving recognized faces, improving model accuracy with larger datasets, or exploring advanced architectures like FaceNet. Thank you for joining me in this tutorial on facial recognition using TensorFlow. If you found this video helpful, please like, share, and subscribe to my channel for more tutorials. Leave a comment below with any questions or topics you'd like to see next.